Hi guys. We're going to be doing some systems of inequalities, practical problems, the word problems and stuff today. So I will put these notes on my website so you have them, so you don't have to copy any of this. If you want, you could print or just you'll have it handy because there's a lot of writing that you'd have to do. So the very first, excuse me, you should read over it. So I'll read it to you. The drama club is selling tickets to the school play. The tickets are $6 for adults, $3 for students. The club needs to raise $1,200 to pay for the costumes and equipment. The auditorium can seat no more than 300 people. Okay, so max is 300 people. The club makes $5 for every adult ticket and $2 for every student ticket it sells. Use the information below. Okay, so all of this basically is put down into a system of linear inequalities that you don't have to set up, which is nice. So X represents adult tickets, Y represents student tickets. Then it asks you to graph. Sorry, I got cut off there, and I don't know what I said right before that. But they give you the systems that you have to use. They tell you that adults are X, that students are Y. And then they give you this graph, all right, representing this over here. It says the graph of these functions is shown to the right, so this is the graph. It is impossible to sell negative number of tickets, which we know that. So X and Y both have to be greater than or equal to 0. Therefore, the functions are confined to the first quadrant. So that's why it's only showing us the first quadrant, because you can't have negative ticket sales. And it gives us the profit function, which is P equals 5x plus 2y. Profit is what the school is going to make. So basically, the things that I want you to take away from this is that, let me highlight it in yellow, the auditorium can seat no more than 300 people. Okay? So basically, that just means that we can't sell any more than 300 tickets. And then the question asks us, how many tickets of each type should be sold to maximize the total profit? So to make the P as big as you possibly can. All right. So the graph gives us several different points. The takeaway here is you want the sum of the two sets of tickets, your X value and your Y value, to equal 300, because 300 is the total amount of tickets that you could sell based on the seating that's available. So if you look at your first line, this red line over here, it gives you this ordered pair 0, 400, which means what this represents is that they sell 0 adult tickets and 400 student tickets. Well, that's nice, but that doesn't work for us because 0 plus 400 equals 400. We can only sell 300 tickets, so I'm going to cross that off. I'm not using 0, 400. The second ordered pair they give us is 0 adult tickets, 300 student tickets. 0 plus 300 is 300, so I'm going to leave this as an option. The next ordered pair is 100 adult tickets, 200 student tickets. 100 plus 200 is 300, so this is also a possibility. Down here, we have 200 adult tickets, 0 student tickets. And though this is a possibility, it probably won't maximize our profit. All right, it probably won't be the biggest because we're not selling out all of our seats. So I'm not going to use 200 and 0. And lastly, we have 300, 0. So 300 adult tickets, 0 student tickets. 300 plus 0 is 300. So I'm going to use these 3 ordered pairs, and I'm going to put them into our profit function to see which one of these choices gives me the biggest profit, which is the goal. So the first ordered pair I'm using, let me make this a little bit bigger, is 0, 300. So x value is first, y value is second. So what I have here is 5 times x, because here's our profit function, I'm sorry. P equals 5x plus 2. So I'm just going to substitute in 0 for x, 300 for y. So 5 times 0 plus 2 times 300 equals 5 times 0 is 0, 2 times 300 is 600. So this profit would be $600 if they sold to 0 adults and 300 students. That's one option. The second option, I'm going to change my color here so we don't get confused, is we could sell to 100 students, or adults, I'm sorry, and 200 students. So 0 adults here, 300 students, 100 adults here, 200 students. We're going to plug this into our profit function, which is p equals 5x plus 2y. So 5 times 100 plus 2 times 200. And our profit, if this was how many tickets we sold of each group, we'd have 500 plus 400, which is $900. Oops, let's put a dollar sign. So our profit would be $900 if we sold to 100 adults and 200 students, which is better than our first option. So far, I'm going with this 100, 200. Well, let's just check out our very last option. Our very last option is if we sell to 300 adults and 0 students. Plugging these two numbers in for x and y in our profit function, we'd have 5 times 300 plus 2 times 0. 5 times 300 is 1,500 plus 0 equals 1,500. So the biggest profit here is 1,500. So that's what you're going to go with. You're going to want to sell to 300 adults. That's what that means. And 0 students if you want to maximize your profit. I don't know what kind of a fun time that would be at the school play if no students are watching, but if you want to make money, that's how you're going to have to do it. And A would be your choice there. All right. The next one. It says Jake is building a fence around his property. He wants the perimeter to be no more than 100 feet. He also wants the length to be at least 20 feet longer than the width. If he builds the fence according to these limits, which would be the maximum possible width of the fence? Before we even get started, we need to talk about a couple of these words here. We got the words no more, and we got the words at least. Back in unit, I think it was unit 5, we talked about these words. No more than less than or equal to. Okay. And at least is greater than or equal to. They're the symbols that go along with it. So no more than or at most, less than or equal to. At least is greater than or equal to. No more than, oh, I should write at most for future reference. Okay. So let's go back, check this out. The first thing that he gives us is he wants the perimeter to be no more than 100 feet. So perimeter is 2W plus 2L. I'm going to make it a capital. No more than, so less than or equal to 100. The second thing that he gives us is that he wants the length to be at least. So our length is at least, I'm just typing what I'm seeing here, 20 feet longer than the width. So 20 feet longer than, which is plus, the width, which is W. He wants to know which would be the maximum possible width of the fence. So he wants us to use these two inequalities to figure out what W is. Okay, and W will be the maximum possible width of the fence. So we could use substitution here. We know that L is greater than or equal to 20 plus W. So all you're going to have to do is you're going to take this and substitute that in for L. So I'm going to take that. I'm going to write 2W plus 2 times L, and now we know L is 20 plus W, less than or equal to 100. So you're going to have to distribute the 2 through. I don't know why that came out like that. It's okay. Giving you 2W plus 40 plus 2W less than or equal to 100, which is, combined like terms, 2W plus 2W is 4W, plus 40 less than or equal to 100. Subtract 40 from both sides. Gives you 4W less than or equal to 60. To solve for 4W, you have to divide by 4. So we're going to take this, divide both sides here, this side and this side, by 4. To get, you also draw a line under here. I have to make it looking like some proper math is going on, you know? So, W is less than or equal to 15 feet. So the choice that goes with that is A. There you have it.